Okay, thank you. So good morning, everyone. I'm Mingzhu from City University of Hong Kong. So today I will present our work on 3D for body post-emission of construction machines. So we all know that construction machines are very, just the critical and also the essential elements on construction sites for different activities. But I don't know whether you're aware of that. Actually, most or many of construction accidents that occurred on site are related to construction machines. So if we look at these statistics about the different causes for incidents of construction sites, and we can see that apart from falling from height, contact with objects is the major reason for the construction accidents. And this is highly related to the movement of construction machines on site. There have been many different incidents related to the movement and the wrong implementation, also the breakdown of construction machines over the world. So that's why previous studies actually trying to look at how we can utilize different machine learning or computer vision techniques to help us to monitoring the motion of construction machines on site so that we could know, for example, where are the machines and what activities are the machines and to evaluate the current safety conditions. So studies have focused on tracking the location and the postures of workers and the machines across different construction sites. And with that method, we can evaluate the safety index of the construction activities so that we can provide some warnings. But most studies look at the fixed, location of construction machines, while the, the posters of machines would actually increase the damage or the injuries to construction workers as well. So by estimating the posters of construction machines, actually we can evaluate, the motion of the machines and provide some supplementary data about the potential risk for construction workers. That's why existing studies, they explored how we can estimate the posture of machines like excavators or other machines using computer vision techniques. But most of them focus on 2D, from the 2D and then based on the videos or images to estimate the postures. So we know that before the era of deep learning, this type of methods will require us to design very complex feature extractors. So this is not very efficient. In our previous studies, we tried to explore how a deep neural network can help us to estimate the 2D postures. So we collected like over 200 videos and to develop a deep neural network framework to estimate the 2D postures from those videos. And then eventually we can, to predict this kind of 2D postures of the excavators. But in this process, actually, we can only obtain the 2D coordinates of each joint of the excavators without the depth data. But if we can obtain the depth data, it will help us to better evaluate the 3D spatial relationship between the coordinates of the excavators and its surrounding workers. Of course, there are some studies already look at the like stereo vision and DNN to address this problem, but they are very limited and they focus on the partial poses. So how about the full body postures that consider different elements of the excavator so that we can have more comprehensive evaluation? That's why in this study, we also leverage stereo vision. So some of you may be familiar with this one. So basically, we have 2 or more cameras to capture the same objects at the same time. And then we try to find the correspondence among the image pairs. And then based on that, we estimate the disparity and get the depth data of the coordinates of the key points. But the challenge is that, especially for construction machines, their movement or the environment is quite complex. So how can we find the correspondence between the image pairs? So this is the major challenge in our previous work. That's why we think about that, okay, we have done some works in 2D posture estimation. We already know the location of the joints in each frame of the video. And then that is the information that we can leverage as the semantic information for us to do the triangulation. But the thing is that I've mentioned we need to collect a lot of data, okay, for training the 2D posture estimation model. That's why we think about that method called deep active learning, so that we can use minimum amount of data that is really required by the deep learning model. And then we also think about how we can select most useful data from the unlabeled ones, so that we can train this model, but reduce the effort for the labeling process. So in this process, we need to think about an effective strategy to do the selection of the images that are useful. That's why our overall framework looked like this. We have 2 main modules. First, we perform the 2D poster estimation from those videos, okay, and then we get the 2D poster. And after that, we do the coarse-to-fine stereo matching so that we can get the 3D depth data of the key points. As mentioned, in this process, we need to find effective strategy. So that is why we use entropy-based methods, use entropy as the uncertainty measurement for the images, so that the images with high uncertainty will be used to be selected for the labeling. Other images, we will not select them. In this process, we can reduce the data labeling efforts. And after that, we can get the 2D coordinates of the key point and use that to do the stereo matching. But this is just the core step, because we will have the errors from the deep learning model. And that's why we will have this refinement process, where we have this template patch, and also we have the search region in the second image, so that in this process, we can use the sliding window process to find the exact correspondence between these 2 key points. In the experiments, we collect over 1,000 image pairs, but we use the toy excavators as a preliminary study due to the difficulty in collecting the real data. And using this data for testing our framework, as the results show that we can significantly reduce the requirement of data from over 4,000 images to over 700. So this can dramatically reduce the time for us to prepare the data. So these are just the graphs that you can read from our paper as well about performance for different key points. And in terms of the 3D estimation, so we can see that not only our data can perform the estimation for all the key points compared with other studies, but also our method can significantly reduce the error for estimating the coordinates for different key points. So compared with other methods, this is good achievement. To conclude, in this work, we have proposed a framework for full-body poster estimation for the 3D coordinates of the key points of excavators. And in this process, by applying the deep active learning, we can significantly reduce the data requirement. And also using the coarse-to-fine stereo matching, we can improve the estimation accuracy. But obviously, we need to conduct the data collection from the real construction site so that we can validate our framework using the real data. Okay, so that's all for our work. Thanks for your listening.